We'll start with defining H0, right, which is our origin, H0, okay, H0, which is the origin frame, and I'll call it EYE4 because this is an identity matrix, right? It actually represents these, no rotation, this is your origin or frame 0. I'm just going to comment this here as frame 0. Okay, so if I want to plot this, what I'll do is I'll say TR plot, okay, H0. Okay, TR plot H0, that will plot the axis for me. I'm just going to save this, save it as anything, I'm just going to call it as example.
H0 as?
H0.
Professor, do we write the percentage frame 0?
That's a comment, right? If you want to comment it, you can write it like that. Okay, so now if you look at this, and if you look at the board, the X is properly aligned in the upward direction. You can just rotate this to make sure that it's like this, right? Now, this is Z0, X0, Y0, Z, X, and Y0, right? So we have some perspective of this. What I'm going to do is, we can comment this and make it like this. So what I'm going to do is, I'm going to say H0, comma, frame 0, I'll label this as frame 0, and I'm going to set an axis, okay? Axis is how much plotting area do you need in 3 dimensions. So let's say that I want to do -2 because I'm going, if this is 0, I'm moving till here, so I'll do -2. In upward direction along Y, I need 1, so I'll just say 2. So this is X minimum to X maximum, okay? Then we have Y minimum to Y maximum, so I'll say -2 to 2. Then we have Z minimum to Z maximum. So I'll say, let's say -2 to 2, okay? X minimum, X maximum, Y minimum, Y max, Z minimum, Z max, okay? If you want to specify a particular color that you want this in, you can also do that, but let's not obsess about that right now, okay? So, let me go here. I think frame. Okay, so now you have the frame labeled as F0, Z0. Alright, so these are aligned, Z0, X0, and Y0. So you have Z0, X0, and Y0. Let's try to plot this, okay? So we have the transformation H01. Let's set up H01. H01 is translating along Z, and then you have 2 consecutive rotations, right? So translate zero, 0, 1, because you're translating along Z by 1 unit, times T rotate X times pi by 2, okay, times T rotate Z by -pi by 2. Okay? All right. So what I'll do is, once I do this, I want to plot the second axis. I'll again say TR. Actually, I'm gonna TR plot. Okay. Now here I'll say H01. We'll call it as frame 1. and let's give it a different color. So I'm just going to call, let's color it in red. So I'll just say R. R is for red. So, okay, I don't see the second frame. Oh, I'm sorry. So we want to plot this on the same plot. We don't want a different plot. So what we do is we hold on to the figure. See what it's doing is right now it's plotting the second one. It's erasing the previous plot that we did for this. So you're only seeing frame 1. If I run this, you'll see frame 1 because we are labeled this as frame 1. You're seeing 1, but you have lost frame 0. So to hold on to frame 0 here, what you'll do is you'll just mention here hold on. So it will hold on to that figure and it will superimpose the second figure on top of it. Okay, so now you can see both frames together. Okay, because this is exactly 1 unit, it's a little overlapping because each of these are 1 units in the scale, which is why you have it like that. But if I make this, if I really want to make this 2, you'll see the difference just for the sake of, okay. So now here you have the 2 frames. So let's say, let me write here color R. Okay, so these are spaced out. Obviously, in our example, if I make this one of the axes will overlap, as you know. Okay. Now what you can do is if you want, you can set up an animation here. So what I'll do is I'll say TR animate. We are going from H0 to H01. Okay, so you should see this frame translate and rotate to coincide with the top frame. Okay, you should be able to see this frame move from here, rotate and coincide with this one. Okay, so if you run this, you will be able to see that the translation and rotation happens at the same time. The frame will move from the origin and will translate upwards like that. Okay, so now let's first set up. I'm just going to comment the animate part for now. I'm just going to comment it. We'll come back to that later. This was just to demonstrate how the frame happens. Let's go set up H12. Okay. So H12. H12 is translate. So these two can be composed. We can write this as one command here. This can be written as X is 1, Y is 0. Right? And then we have rotate by X. And rotate by Z. Rotate by Z by pi by 2. No, once you put on hold on, it holds on to the same figure. There is no need to do that again. Once it holds on to the basic figure, all the other consecutive figures are superimposed onto that. Okay? Alright. Now, when I do TR plot here, you'll see a difference, and I want you to tell me why this happens. Okay. Now, what I want to explain here is that when I do this, this will not align with the 0th frame. You'll get something else. So this is, if you look at this, this was, where is that? Okay, fine. Here it is, right? So the 0th frame is exactly how we want it. This is Z0, Y0, X0. You have Z0 going up, Y0, X0. This frame is also right, but this frame is wrong, even though we set it up properly. Why? So Y2, if you see, it should be to the left of X0, right? It should be to the left on this side of Y0. It should be here, but it's actually dropped here. What? Huh? Any answer? Why is it, instead of to the right, why is it gone down? I'm sorry, instead of to the left, why is it translated downwards? The reason is simply because the transformation here is defined from 1 to 2, right? But when you do TR plot as like this, it will take it from the origin, so it will calculate from here. In this case, you have negative Z1, so it is dropping from here. So if I want to take this, if I want to, since H1, 2 is defined from here and not from here, when I want to plot this, I'll have to write it as TR plot, because everything is with respect to the origin. Okay? Because you are translating this from here. This translation is defined with respect to frame 1. It's not defined with respect to the origin. The plot command plots it with respect to the origin. So when you have Z minus 1, it is dropping it down to the inside. So what I'll do is, I'll just change this here. If I write this as H01 times H12, and if I run it, you'll see that all the three are exactly how you need them. This is 0, 1 is here, and 2 is here, right? Now you can do a clear animation here. We can set up a animate from here. I'm going to bring this down. I'm saying Control X. We'll set up both the animation commands here. This is the first one. And then we move from H01 to, we are moving to H0, H12. Okay, I'm just going to give a pause command so you know how it happens. All right. All right, so let's look at this. I have to press a command. I just press a key there because I have a pause. If you press a key, then it will continue the animation. Okay, it's going there, see? So what we have to do here, let's go back here and say H01 times this, okay? H1. And within pause, just give it as 1. So it will pause for automatically for 1 second and you don't have to press a key like that. That will just pause it for 1 second. So now if you run this, alright, so you'll see you can always adjust this. These are the size of the axis that we defined when we were defining this part. So you can, when we were defining the axis here, this is where you define how much plot area you need. You can always change that. Alright. So always make sure that when you're going like this, you always have to consider that when you plot it, if the transformation is from 1 to 2 like this, you always have to multiply it by the earlier transformation from the origin, because what defines this axis is a transformation from 0 to 1. If you miss out that, then this will not be pieced together, because this transformation, the basic transformation is missing. Unless it has data about how this was defined, you cannot define a relationship between this and this. You cannot visualize the relationship between the other two axes. Okay?
Can we please watch one more time?
Sure. All right. Within parentheses. Pause one is within parentheses, right?
Professor, in the last command, why do we need to multiply H01 by H12?
If you don't multiply H12, the transformation is defined with respect to this origin frame. It does not have information about this frame, right? It does not know, okay, if I give you a transformation, right? We know the transformation here, like this, because we read it like this, right? The system does not know that, because the system only reads the matrix. So it will assume that it is defined with respect to the origin. We know that it is defined with respect to the frame 1. We just define this as a variable, right? I mean, this is just a variable. It doesn't mean anything. But for us, it means, because we read it as it is a transformation between 1 to 2. Okay? But by default, the system will take it as from the origin to that. So if I want to consider this part, then I have to multiply it by frame 1 is defined like this, and then the second frame is defined. Okay? Alright. So what I want you to do is basically, you did a homework where you defined all the frames for this problem. The problem that I gave you as homework, right? So I want you to plot all the frames so that they exactly line up as it is shown here, right? You have all your transformation matrices that you have solved from your homework. You'll plot them exactly so that they line up, and check your answer. That way you can also check your answer if it's the correct one or not, okay? And you'll submit the plot along with your assignment. Okay, so what you'll do is basically, I don't know how many frames are there. There is a 4 frames, right? Just write down the 4 frames on the piece of paper and you'll submit the assignment. With that piece of paper, you'll attach your MATLAB plot. Okay, with the 4 frames that you copy, you'll copy these, right? Basically, you have H01, then you have H12 or H23 and H34, right? That's what you have, 4 frames, or you can have as 01, 04, 03 and so on, whatever. So once you have those, you just write down the matrices and you can submit the assignment. What I want you to do is go along the lines of what we did here. Forget the animation because you cannot submit the animation. You just plot the 4 frames and make sure that they exactly line up. According to your answer, they should line up as the problem shows, right? If you look at this figure, when you plot your matrices, all the frames should be exactly like this, right? Because what we did in class, we wrote the matrices, homogeneous matrices for this, right? And we checked that whether it aligns exactly like that or not. So you have your assignment, just write down the 4 homogeneous matrices that you derived and make sure that you plot them to see that they exactly align like your assignment.
We are still yeah,
What is the missing? No, it's 0 to this, not 2 to 0. It's 0 to this. Look, read the question.
Yeah, I have the same question here. So,
Okay, it says
so each of these frames to the base frame.
to the base frame, right?
1 to 0.
To the base frame. So with respect to the base, when it says in relation to the base frame, that means your base frame is the reference, right? So this will be H02. With respect to the base frame, you are comparing this frame with respect in relation to the base frame. Okay?
So this is what is going from 0 to
So let me tell you, okay, if I tell you that, tell me my location with respect to New York, right? Then New York is the reference, right? I'm referencing myself with respect to New York, right? So if I tell you that, what is the translation or what is the homogeneous transform of this frame with respect to the base frame? Okay, base frame is the reference. Okay, so with respect to the base frame, it will be like this. If I write it like this, 2 is the reference and I'm moving from 2 to 0. Okay, with respect to which frame you're doing this, that frame will be your reference frame. Okay, you're relating yourself to that frame.
So we are moving from 0 to 2.
Exactly. You're moving from 0 to 2. When we discussed the R3 by 3 matrix, we said, what does it signify? It tells you what is the rotation of the current frame with respect to the original frame, right? It is a transformation of the it defines the orientation of this frame with respect to the original frame. So when you do this, it means that this is your reference. When you do this, 0 is your reference.
So what we need to find is for
Yeah. Let me read the question clearly so that you know what frames are need to be found out. Okay, so cube measuring so and so, camera is situated there. Find the homogeneous transformations relating to each of the frames to the base frame, right? So everything relating to the base frame. So 0.
We don't have 4, just 1.
So 1, 2, 3,
1, 2,
0,
3.
1, 2, 3.
So another question here. For the second frame, should we avoid hitting the table or which one? Or this one? So we need to. What do you mean? Or just ignore the table? What do you mean ignore the table? For example, because this is a cube here.
Yeah.
So if you want to go to there, we were gonna.
That's fine, don't worry. It's a transformation. It's
Yeah,
not that-
because it says cube measuring is 20 centimeters, which means that.
Okay, I'll tell you why. So there is a question here which gives you the dimensions of the cube. So the cube is sitting on this table. Basically all it means is when you take 20 centimeters as side of the cube and the axis is located exactly at the center, this height will be 10 centimeters. Okay, so that is for you to take into consideration. This is 10 centimeters, this exactly 10 centimeters and 10 centimeters because it lies exactly at the center of the cube, right? So when you do let's say that this is my reference. For example, this is my reference, right? This is x0, y0, and z0. Forget about the rotation. If this is my frame, I have to set up a translation by 10, 10 here. It will be this distance along x. Along y, if this is y is rising from the face of the table, so this will be 10 centimeters. And z is moving in the negative direction, right? You're moving backwards in the z direction, so this will be negative z, let's say. Okay? Got it? So it's like this. So if I have this as, this is the face of the table and this is the cube, right? So if this is my axis, the axis lies for the cube, the frame is exactly at the center, right? So I have to move back to the center. In this direction, I have to move to the center, which is, let's say my center is exactly lying here, right? So I have to go here, like this, and also I have to rise to the center of the cube.
Okay.
Which is why the dimensions of the cube are given, so that you can go up till half the length.
Okay.
Please label the frames so that we know which frame is which. So each of the frames will be, you'll give them as, table frame will be 1, 2, 3, 4 and so on. Okay, the first thing I want you to do is, because you'll be submitting the assignment, just write down on a piece of paper, write down your 4 matrices, okay? Because you'll take that home and you'll submit that with the code and the output.
Are we gonna submit anything today or?
No, you can submit it Tuesday, but you'll submit the assignment today. Like whatever you did, your homework, the matrices that you calculated, you'll submit that. Okay? Just write down the 4 matrices or just take a picture so you can set it up like this, right?
So let's just on the paper, right?
Okay, now, if you go to Help Robot, you will find that okay, now these commands will give you 3 by 3. Okay, T rotate will give you 4 by 4. Rotate X. So there is a difference between these 2 commands, right? So this will give you R3 by 3. Rotate X by an angle will return R3 by 3. Okay, so you can do X, Y, Z. T rotate X. Okay, will give you H4 by 4. Alright? So this letter will define that this is a 4 by 4 matrix. It's exactly the same thing, only thing is it is nested. This will return a 4 by 4, this will return a 3 by 3. So this is nothing but this will be 0 because there is no translation involved within this. Yeah, negative. Yes. It depends on which is your reference frame. So if you take this as a reference, then this is positive, right? But if you take this as a reference, this is positive. No, it depends on where you're starting. If you're starting from this frame, this is the positive direction. If you're starting from this frame, this is the positive direction of Z.
Okay, you
Any questions? You have done the calculation, you have actually simulated matrices, and you have given me that data. Okay? So you plot all of these that you have found out and make sure that they exactly align as they are shown in the question. Okay? Everything. Just write down the matrix, right? This is T, 2, 2, 3. So write down that for this question number 1. So you do question number 1, okay? You simulate question number 1 of your assignment.
No, but now I'm gonna write down this code for this one. I'm gonna need this code. This is actual. No, but I need to go here.
Yeah.
That's all what it is. How am I supposed to write this? I don't know how to write it. Watch it move right front, yeah.
Power on, part release of I do something again, I can't just something more. Right, base.
Franklin, can you pull up the assignment question?